Hello everyone. So today we will discuss the experiment of three-phase power measurement using virtual lab. So here you can see I have entered the website vlab.co.in. So this is the website of virtual lab. So here in the electronics and communication branch, after clicking, we can see there are various labs. In that there is one lab is given, that is analog signals network and measurement lab, developed by IIT Kharagpur. So after opening this, we have to click on list of experiments. So here different experiments are given. So in that, at the sixth number, the three-phase power measurement experiment is given. So after opening that link, we will see this experiment. So there are different types like theory, procedure, operating environment, simulator, quiz and references. So here objective is three-phase power measurement by 2 wattmeter method. So here we can see the circuit diagram or connection diagram is given. So in that first wattmeter current coil is connected in R phase and pressure coil is connected between R and Y phase. For the second wattmeter, current coil is connected in B phase and pressure coil is connected in between B and Y phase. So here detailed theory is given. So here if star connected circuit is taken as an example, the total instantaneous power consumed in the circuit is given by this equation. So here equation is given, and here for total power measurement, that is given by W1 plus W2. So here all the equations and theory is given, as well as the phasor diagram of three-phase balanced star connected circuit is also here mentioned. So you can go through this theory. After that, procedure is given to perform this experiment. Here you can see procedure for balanced load and procedure for unbalanced load. So detailed procedure, stepwise procedure is given. Now we will perform this experiment. Here simulator is given. So link for the simulator is given. So here to perform this experiment, I am opening that simulator. So this experiment is divided in two parts. First is for balanced load and second is for unbalanced load. So first we will discuss about balanced load condition. So in the procedure, first step is set the three phase, that is line to line voltage for 100 volts and frequency for 50 hertz. So here you can see the three phase line to line voltage in volts is 100 and frequency is in hertz, that is 50. Second step is set the balanced load value. So here you can see balanced load. Here all three values of all three resistances are same, that is for balanced load, and it is 25 ohms. So we can set this value. Now I am entering 100 ohms for all the three resistances. Here you can see the value is now 100 ohm. Next step is switch on the supply to get the meter readings. So I'm switching the supply for on condition. So now here both the meters are showing the current readings, as well as both wattmeters are showing power readings, and here voltmeter is showing the value as a 100, as a 100 volts. So now click on the fill the table button to update the observation table. So here, if I am clicking on this button fill the table, then I am getting the values in the observation table. Now next is compare calculated power WC with the measured power WM for each observation. So here we have to compare these two values WC and WM, that is calculated power and measured power. So here WC is 99.99 and WM is 100. So both are almost equal. And last step is change the balanced load value to take another observation. So now here the load value I am changing it for the 90 ohms. So here values are changed. Then again I am switching on the supply and clicking the fill the table. Likewise I am performing for 5 readings. So here this observation table is given for 5 readings. So almost we have observed 5 different values or for 5 different readings. So here in all cases you can see for second readings it is almost equal, that is 111.11, both are readings are equal. For same, for all these 5 readings, calculated power and measured power both are almost equal. So in this observation you can see voltage between R and Y phase, then current flowing through the R phase, then power factor, then second voltage between two phases, then current flowing through the B phase, again power factor for these two readings. So here the different wattmeters, that is W1 and W2 readings, and last two columns are for calculated and measured power. So this is the procedure for balanced load, and here one note is given, that is click on the fuse indicator to repair it if it got fused. Okay, if here I am setting this voltage line voltage as a 500 and clicking on the supply. So here I am getting this red cross button. So this fuse is this fuse is blown out. So to repair this I have to click on this. Now fuse is in good or working condition. So this is for balanced load condition. Now we will go for unbalanced load 3-phase power measurement. So here you can see circuit is same for this experiment or this part, but here all the three resistances are different in values, while in balance all these three values are same. Also here voltage between R and Y phase is different from this voltage between Y and B phase. Now we will see the procedure and we will perform this. So first is set three phase line to line voltage to 100 volt and frequency 50 hertz. So here voltage between R and Y phase is 100, voltage between Y and B is 150, and frequency is 50 hertz. Now second, set the different values for R1, R2 and R3. So here by default values are different, 120 ohm for R1, 160 for R2 and 180 ohm for R3. Now next step is switch on the supply to get the meter readings and click on the fill the table button to update the observation table. So now I am switching on the supply and clicking on the fill the table button. So I'm getting the values in observation table. So here all the three voltages VR, VY, VB and all the three phase currents IR, IY, IB, then calculated power WC, W1, W2 both wattmeter readings and measured power W1 plus W2. So here next step is compare the calculated and measured power for each observation. So for this observation here 252.16 and here 253.86. So both are almost nearly equal. And last step is change the values of R1, R2, R3 to take another observation. So now here for next reading I am changing this to 100 and second as 150. So I am performing this for different readings. So here we can see I have performed this for 5 different conditions or for 5 different readings, and here now for second 266 calculated power, here 267 watts, like here 712 713. That means like balanced load we have seen calculated power is almost equal to the measured power. Similarly here for unbalanced load is also we are getting the same results. Calculated power say, approximately same with measured power. So in the similar way you have to perform this experiment. Thank you for watching this video.